Starship is not just another rocket aimed at launching satellites. It's designed for much grander goals, one of which is to return Americans to the moon after decades. This ambitious goal is part of NASA's contract for a special version of the Starship, called the Human Landing System. However, there have been some problems that have caused concerns at NASA, which might lead to major changes or even the cancellation of this program. We'll cover this topic in our video today. Before we get into the details, please make sure to subscribe to our channel for more updates on Starship and other major achievements by SpaceX. Most rocket companies focus on a single mission, which is developing spacecraft and launching them with a client's payload, similar to how one might rent a car for occasional use. However, SpaceX operates differently. They don't just launch satellites, they also create and deploy their own, such as the Starlink constellation, which aims to provide global broadband internet coverage. This project serves both as a business venture and a strategic step toward funding the company's more ambitious goals. Our topic today centers on another very important project SpaceX is working on, which is the Human Landing System, or HLS. The Starship Human Landing System is a variant of SpaceX's Starship spacecraft, designed for NASA's Artemis missions aimed at returning humans to the moon. Unlike other lunar lander designs, the HLS is intended to be fully reusable. It is developed under a substantial contract with NASA valued at $2.9 billion. This contract includes the execution of an uncrewed demonstration mission, followed by a crewed lunar landing, initially planned for no later than 2024, but now facing delays. The original timeline has been pushed back several times, with the first crewed lunar mission now rescheduled for September 2026. During a recent update from SpaceX's Boca Chica facility, Musk disclosed significant issues with this program, particularly the spacecraft's reduced payload capacity and ongoing engine challenges. Previously, Starship was expected to carry between 100 to 150 tons to low Earth orbit. However, this capacity has now been revised down to about 40 to 50 tons. This drop isn't because they changed the rocket's size or the type of fuel it uses, which have stayed the same. Instead, it seems to be because they've added new features to make the spacecraft safer. These might include better shielding to protect against space debris and using stronger materials to help the spacecraft last longer. This change has big implications. Even though Starship can now carry less than before, its capacity of 40 to 50 tons is still pretty good, especially compared to older spacecraft like the Space Shuttle, which could carry about 27 tons to low Earth orbit. This means Starship can still carry more than the Space Shuttle could. However, the reduced capacity could affect missions involving human space travel. Fewer supplies or smaller crews might be sent up at one time, requiring more trips for big projects like building bases on the Moon or Mars. SpaceX has also added extra shielding around each of the 33 engines on the Super Heavy booster. This additional mass directly decreases the payload that the rocket can carry. In addition to the extra shielding, SpaceX has installed a steel hot staging ring on the Starship. This ring is an important feature, as it allows for the engines to be fired while the booster and spacecraft are still connected. The concept of hot staging is not new, and was prominently used in Soviet-era rockets like the Soyuz. Hot staging involves igniting the engines of the next stage before the current stage has been completely discarded. This method eliminates the need for complex ignition systems in the vacuum of space and reduces the time between stage separations. Although this modification is intended to increase the overall efficiency of the spacecraft by about 10%, SpaceX has not yet confirmed whether this theoretical benefit has been realized in actual flight conditions. The additional weight of the steel hot staging ring does have the drawback of reducing the overall payload capacity that the Starship can carry into orbit. The principle behind these changes can be explained by the rocket equation. This equation relates a rocket's payload capacity to its mass and the specific impulse of its engines. Essentially, any increase in the mass of the rocket's upper stage necessitates a reduction in payload capacity, as both need to reach orbit. The additional safety features compromise the payload efficiency of the Starship. This diminished payload capacity has serious implications for SpaceX's planned missions, including the Artemis program, which aims to return humans to the moon. The Starship HLS, specifically designed for lunar missions, now requires more fuel and potentially more refueling missions to accomplish its objectives. More refueling missions increase the complexity, cost, and duration of the lunar mission. For instance, if the payload capacity remains at the lower limit, the number of required refueling flights could double. This scenario complicates the logistics of the mission, requiring a greater number of launches and more planning and coordination. Moreover, the reliability of the Raptor engines, which power the Starship, is another concern. The development of the Raptor 3 engine, which provides 22% more thrust than the Raptor 2, is critical. However, if these new engines fail to meet performance expectations, it could lead to delays in certifications and consequently push back the timeline of the Artemis mission. In response to these challenges, SpaceX may need to develop new variants of the Starship with higher payload capacities. With the current variant of the Starship, SpaceX has already conducted 3 orbital flight tests and is now preparing for the 4th one. The first test, conducted on April 20, 2023, aimed to demonstrate the integrated capabilities of Starship with the Super Heavy booster. Unfortunately, this ended in the vehicle being destroyed shortly after liftoff. Despite this setback, the test provided valuable data on the vehicle's performance and integration dynamics. The second test saw improvements over the first, with significant enhancements to the launch pad and vehicle design, particularly the fire suppression systems and the hot stage separation mechanism. This test achieved a partial orbit, though it too ended with the booster's destruction due to issues during the boostback burn. By the third test on March 14, 2024, SpaceX had made further adjustments. This test marked a significant achievement as the Starship successfully completed a full-duration second-stage burn and reached the intended orbital velocity for the first time. However, the vehicle broke up during re-entry into the atmosphere. Despite this, the test was considered a success in terms of achieving several key objectives, including a propellant transfer demonstration in orbit. SpaceX is preparing for the 4th test flight of its Starship vehicle, which could happen as early as the beginning of May. The analysis from the 3rd flight is currently being used to make necessary adjustments for the upcoming test. This test will focus on improving the re-entry and landing processes, crucial steps towards SpaceX's goal of developing a fully reusable spacecraft. Launching a rocket is one of the hardest feats to achieve in science and engineering, but there's one challenge that surpasses even the launch: landing a rocket. This is mainly due to the high speeds, the need for precise navigation, and the brutal atmospheric re-entry conditions. A rocket returning to Earth must decelerate from speeds that can exceed Mach 25, and this requires precise control over its engines and aerodynamic surfaces. This deceleration must be timed perfectly to ensure the rocket slows down enough to make a controlled landing. Then there's the issue of atmospheric re-entry. The rocket must endure extreme heat due to friction with the atmosphere, which can heat the surface of the rocket to around 1,650 degrees Celsius. This requires robust heat shields that add weight and complexity to the design. The landing itself requires the rocket to execute a series of controlled burns to slow down and touch down precisely at a landing spot. It's ironic that despite many rocket companies and organizations like NASA launching rockets since the 1950s, it was a newcomer like SpaceX that first successfully achieved the idea of landing and reusing rockets. Traditionally, space agencies around the world treated rockets as expendable items. A typical launch involved using the rocket to propel payloads into orbit, after which the rocket components would generally fall back to Earth and be destroyed or lost in the ocean. For decades, this method was accepted as the norm due to the immense technical challenges and costs associated with trying to recover and reuse these massive structures. The focus was on ensuring the payload reached orbit rather than the fate of the rocket itself. However, when Musk founded SpaceX in 2002, he approached space travel from a different angle. He saw these traditional methods as wasteful and a huge barrier to making space travel more accessible. SpaceX began testing its reusability concept with the Falcon 1, but the major breakthrough occurred in 2015, when they successfully landed the first stage of the Falcon 9 on a landing pad at Cape Canaveral. This was followed by the first successful landing on a drone ship in April 2016. Although SpaceX has successfully landed Falcon rocket boosters, it's important to note that these rockets are not fully reusable. The Falcon system typically recovers only the first stage, while the second stage and other components are not designed for recovery and reuse. This is why SpaceX is focusing more on the development of the Starship. Unlike the Falcon rockets, Starship aims to have both its stages, the Super Heavy booster and the Starship spacecraft, return to Earth and be reused. The Starship system works in two main parts, the Super Heavy booster and the Starship spacecraft. The Super Heavy lifts the spacecraft into orbit and then returns to land on Earth, similar to how the Falcon 9's first stage operates. Currently, SpaceX is focusing on perfecting the recovery of the Super Heavy booster. Once they have reliably achieved this, the next phase will involve working on recovering and reusing the Starship main stage. Recovering the Super Heavy booster of the Starship is way more challenging than landing the smaller Falcon rockets. The Starship is almost double the size of the Falcon 9, making its recovery double as difficult. So, traditional methods like those used for the Falcon boosters aren't suitable due to the Starship's scale and mass. To solve this, SpaceX has introduced the Mechazilla arm, a new system designed to catch the Super Heavy booster upon its return to Earth, eliminating the need for splashdowns or traditional ground landings. This new method requires a precise sequence of events to be successful. The process starts with the booster separating from the Starship after launch. It then performs a boost-back burn to adjust its trajectory back towards the launch site. About a minute after this burn, the engines shut down as the booster enters a transonic phase, preparing for the final descent. At around 6 minutes post-launch, the booster reignites its engines for a landing burn, slowing it down as it nears the landing pad. The engines cut off once the booster aligns over the Mechazilla arm, where it must be caught by the arm's chopstick-like mechanisms. This phase requires highly accurate navigation to ensure the booster lands precisely on the Mechazilla arm. Managing the booster's fuel is a critical aspect of the return journey. The booster must retain enough fuel for navigation and adjustments during its final approach. Running out of fuel too early would lead to mission failure. The navigation system also faces significant challenges due to the precision required for a direct Mechazilla arm landing. Wind and other atmospheric conditions can affect the trajectory, requiring the navigation system to perform flawlessly. To prepare for this complex landing method, SpaceX plans to use a virtual tower system to simulate the Mechazilla arm in upcoming tests. This will allow the team to practice the landing maneuvers in a controlled environment. Protecting the launch infrastructure is also crucial. Repeated landings can pose risks to the launch pad and its systems. SpaceX may need to adjust the landing angle or utilize the Mechazilla arm in specific ways to minimize impacts and protect its equipment. In the next couple of Starship launch tests, SpaceX doesn't plan to use the Mechazilla catching arms. Given the complexities and the potential risks, any problems during the catch attempt could lead to possible damage to the launch tower. Instead, SpaceX will focus on testing other important technologies, such as moving propellant from one tank to another inside the Starship. This test is vital for long-duration missions where refueling in space is needed. They'll also test the opening and closing of a payload bay door, crucial for satellite deployment missions. The Raptor engines, which power the booster, are another focus. Ensuring these engines perform reliably is crucial, as past flights have shown that even small malfunctions can disrupt the landing process. SpaceX conducts extensive testing, including static fires and wet dress rehearsals, to ensure the engines are flight-ready. After the tests, instead of attempting a landing with the Mechazilla arms, the Super Heavy booster is planned to splash down in the ocean. The goal during all the past 3 Starship launch attempts so far was to achieve a splashdown in the ocean, but none of the launches have gone as planned. The initial Starship test flight ended in failure shortly after takeoff. The integrated Starship and Super Heavy rocket successfully launched but encountered a problem with stage separation. This malfunction led to an explosive outcome. The second Starship test flight aimed to build upon the first, but also ended in failure. This time, both the Super Heavy booster and the Starship upper stage experienced issues independently. These separate failures led to the destruction of the rocket before completing its intended flight profile. This flight marked a slight advancement as it managed to execute some planned maneuvers before failing. During this flight, the Super Heavy booster performed a boost-back burn and aimed for a splashdown near the launch pad. Unfortunately, the booster experienced a failure during its landing burn, resulting in an explosion just 462 meters above the ocean's surface. SpaceX is now planning to launch the fourth Starship test as early as May. If you are keen on space news, you will notice that most of the SpaceX updates are made by none other than Musk. There is a reason for this. Besides being the SpaceX CEO, Mr. Musk has a big influence that comes in handy when disseminating news. For example, if you check through his Twitter account, you will see he has a massive following of more than 180 million people, and he is followed in a distant second by Barack Obama, who has slightly above 131 million followers. With such a great following, Musk does not need the mainstream media outlets such as CNN, BBC, Al Jazeera, or Fox News to help him advertise his company or publicize his message. In any case, social media is more effective today in the dissemination of news than the traditional media houses. You will agree with me that you get to see breaking news on Twitter before it is broadcast by either CNN, BBC, or any other mainstream media channel. In this digital age, most young people know that Twitter is the real deal when it comes to spreading of news. By the way, Musk is not just the most famous person on Twitter, but he also owns the social media platform. With that, understand why any news that he posts there will easily spread like wildfire. As an enthusiast of space and rocket technology, there is every possibility that you know that the aim of the SpaceX Starship is to ferry people from Earth to Mars and back. Silicon Valley billionaire Musk surprised many when he revealed that it is possible for the Starship to be deployed for intercity travel around the globe. Musk echoed the same when he said, if you build a ship that's capable of going to Mars, what if you take that same ship and go from one place to another on Earth? We looked at that, and the results are quite interesting. If this idea is actualized, it would be a big win for global transport, since the Starship will travel to any place around the world in less than 1 hour, traveling at a maximum speed of nearly 17,000 miles per hour. A trip from New York to Shanghai, for example, would take 39 minutes down from the current non-stop time of about 15 hours. New York to London could be done in 29 minutes. LA to Toronto would take just 24 minutes, London to Dubai in a mere 29 minutes. It is only logical that Musk's hypersonic rocket travel will succeed if it assures the travelers of uttermost safety, and also have a competitive transport package. Musk has hinted that the cost per seat in the hypersonic rocket will be equivalent to the amount that one pays in an economy class in a commercial aircraft. The cost comes as a surprise, given how expensive space projects can be. But as a tech genius, Musk has always found a way out even in the most challenging projects. As an engineer, Musk turned the rocket business upside down when he managed to make the SpaceX Starship rockets fully reusable. But how did he achieve this? Musk's vision, coupled with SpaceX's innovative engineering, rigorous testing, and risk-taking approach, led to the development of reusable rockets. The journey began with designing rockets capable of guided re-entry, a stark contrast to the traditional expendable method. This feat was achieved through the creation of multi-purpose engines. These engines not only powered launch, but also allowed for trajectory adjustments and landings. With successful landings under their belt, SpaceX pushed for a fully reusable system. This necessitated advancements in both design and materials. A critical innovation was the development of lightweight, heat-resistant materials for the heat shield. This breakthrough addressed a major hurdle, which is the intense heat and pressure encountered during re-entry. The path wasn't solely paved with technical challenges. Financial and logistical hurdles also needed to be overcome for economic viability. SpaceX tackled these challenges through heavy investment in research and development, coupled with strategic partnerships with government agencies and private companies to share the financial burden. Through sheer persistence, dedication, and a willingness to take calculated risks, SpaceX defied expectations and achieved the seemingly impossible: reusable rockets. This innovation has the potential to drastically reduce spaceflight costs, paving the way for a future filled with further exploration and advancements in space. After achieving a fully reusable rocket, the SpaceX team seeks to increase their manufacture of more Starship rockets by opening of the Starbase factory. Located in South Texas, Starbase stands as a pioneer, the world's first true spaceport. It's the nerve center for SpaceX's next-generation Starship program, housing both the rocket factory and launch facilities. Nicknamed the Gateway to Mars by the space community, Starbase is poised to be the launching point for humanity's first crewed missions to the Red Planet within the next decade. The Starbase facility is under continuous expansion to support Starship development and future launches. This could involve building new launch pads, storage facilities, or expanding existing structures. As the development of Starship continues, the SpaceX team of engineers are working on a star factory, where they will focus on producing many Starships per week. The production of more Starships means more launches, which will certainly lead to a greater success. When the Starbase is fully operational, humanity can be assured of achieving the status of a multi-planetary species. Under Musk's plan, his SpaceX company will be making the first uncrewed mission to Mars in 2026. 3 years later, in 2029, he expects to land the first human on the Red Planet. If everything goes according to plan, he will use the next 20 years from 2030 to 2050 to build the Red Planet to a state where it can comfortably support human life. After finishing the construction in 2050, Musk will use the next 10 years to transport people to Mars. According to his estimates, more than 1 million people would have settled on Mars by 2060. You will agree with me that nothing beats the sight of the Super Heavy booster with 33 Raptor engines and the Starship spacecraft with 6 Raptor engines roaring into space. A few minutes after liftoff, every spectator is keen to witness the climax of it all. A successful separation is a big win for SpaceX and Musk. Whether SpaceX can achieve this remains to be seen in the next Starship launch. It is obvious that we will only appreciate the next Starship launch if we get a glimpse of what happened in the previous Starship launch and all the progress that the commercial space company has made so far. A few weeks ago, SpaceX launched the powerful Starship into space in what is so far the longest test flight. The Starship traveled halfway around the Earth, but unfortunately, it disintegrated on its return to Earth after 49 minutes of flying. Nearing Earth, the vehicle came apart at a staggering 65 kilometers. Meanwhile, the Super Heavy booster met a fiery end in the Gulf of Mexico, exploding during its attempted landing burn. If you think this test flight was not a success, you will have to be reminded that the flight was not intended to make it all way around Earth. The main goal of SpaceX in the test flight was to reach orbital velocities of 175,000 miles per hour, which it did. The success of SpaceX was appreciated by one Amy Johnson, who is a Florida-based space journalist, who spoke to Al Jazeera saying, "SpaceX is 22 years old today. The company announced its plans for Starship in 2015. This is the third in-flight test for this rocket system in less than a year, so they are definitely making very big strides towards that goal." The launch was made from SpaceX's private facility in Boca Chica, Texas. As you would expect, the SpaceX team has learned a lot from this previous test flight and will make massive improvements in the next Starship launch. Speaking at the Satellite 2024 conference March 19th, Gwynne Shotwell, President and Chief Operating Officer of SpaceX, said the company was still reviewing the data from the vehicle's third integrated launch, March 14th, but expected to be ready to fly again soon. Before SpaceX can start flying again, they will need clearance from the U.S. Federal Aviation Administration. All signs show that SpaceX will not find it difficult to get a license from the U.S. Federal Aviation Administration after Kelvin Coleman, FAA Associate Administrator for Commercial Space Transportation, said this about the flight. It ended in what we call a mishap, but at the end of the day we deem it a successful launch attempt, he said, because it resulted in no injuries or property damage. SpaceX was able to collect a great deal of data from that launch. Following each Starship flight, the FAA has meticulously revised the launch license to account for mission variations, such as the latest suborbital trajectory. However, the agency is seeking a more streamlined approach with a single portfolio license, encompassing future launches, a crucial step considering SpaceX's ambitious schedule of 6 to 9 additional flights this year. SpaceX President Gwynne Shotwell has revealed the main purpose of the next Starship launch, saying, "I don't think we're going to deploy satellites on the next flight," she said at the conference. "Things are still in trade, but I think we're really going to focus on getting re-entry right and making sure we can land these things where we want to land them." SpaceX CEO and tech genius Musk echoed the same sentiments in a tweet, saying, "Getting ready for Flight 4 of Starship. Goal of this mission is for Starship to get through max re-entry heating with all systems functioning. It is important for the rocket to make re-entry as it is fully reusable. SpaceX's vision of cost-effective space exploration hinges on Starship, a fully reusable launch system designed for rapid turnaround between missions. This translates to both the Super Heavy booster and the Starship spacecraft itself being engineered to return to Earth intact after launch. The booster performs a guided re-entry and powered landing, while the spacecraft utilizes heat shielding for atmospheric re-entry and splashdown at sea for recovery. This revolutionary approach to reusability is seen as a game-changer by Musk, making settlements on Mars and the Moon economically feasible. Starship's selection by NASA as the crewed lander for the Artemis program marks a significant step towards this goal, paving the way for a new era of human lunar exploration. It looks like SpaceX is getting ready to test the giant first-stage booster, called Super Heavy, for its upcoming Starship flight. This test, called a static fire, involves firing up all 33 of the booster's engines for a short burst while it's still held down on the launch pad. This isn't the first test. They've already done similar tests with the spaceship that will ride on top of Super Heavy. This upcoming static fire is another important step in making sure both the booster and the spaceship can be reused after launch. Booster 11, the rocket that will launch with Ship 29 in the next flight, has been waiting on the launch pad since November. It's passed its initial tests, but they need to fix the launch pad before they can test how the booster works with it. The launch pad needs repairs because the hoses that send fuel to the booster got damaged. Once those are fixed, they can test Booster 11 and the launch pad together. Starship, the giant rocket being built by SpaceX, is designed to be the most powerful and fully reusable launch system ever created. This reusability is key to achieving SpaceX's ultimate goal, transporting people and cargo beyond Earth, including missions to the Moon and Mars. Right now, a key part of Starship, called Booster 11, is waiting on the launch pad for its next test. This test, called a static fire, will briefly fire up the booster's engines while it's still held down. They need to fix the launch pad first, though, because the hoses that send fuel to the booster were damaged. Once those repairs are done, we'll see what the next test for Starship holds. Do you think SpaceX will successfully launch the Starship in the next test flight? Feel free to share your views in the comment section below. To this end, thanks for watching and feel free to subscribe to the channel so that you do not miss out on the latest SpaceX news, upcoming launches, and behind-the-scenes insights. Till next time, guys, cheers.